Hello everyone. As promised, I'm launching a brand new series today, AWS Solutions Architect Associate SAA C03. I hope you have already conquered the Cloud Practitioner certification by now. It's a fantastic starting point and lays a solid foundation for exploring cloud technologies. However, it's just the first step. To truly boost your credibility and to make your resume stand out, you need to push further. This is where AWS Solutions Architect Associate certification comes in. It's your next crucial step on this journey. Sure, it's a bit tougher than Cloud Practitioner, but don't worry. This video series will be your ultimate guide, breaking down the complexities and making the path to success clear. So are you ready to take your cloud expertise to the next level? Let's jump in. Welcome to episode 1. We will cover question number 1 to 5 in this episode. Please like, share, and subscribe to get regular updates on new episode releases. Let's get started. Question number 1. For the database layer of its e-commerce website, a firm uses Amazon DynamoDB with provided throughput. During flash sale, the client may encounter periods of delay when the database is unable to manage the volume of transactions. As a result, the business loses the transaction. The database operates normally during regular times. Which approach resolves the company's performance issue? Please read the question, pause the video, mark the keywords, and also identify the problem description. Problem description is going to be key in case of Solutions Architect Associate exam. Every scenario will have a short problem description, and we'll cover that as well. Here is my understanding of the keywords. There is DynamoDB, and there are flash sales going on, which means there is a high number of volume being processed in terms of sales by this e-commerce platform, and DynamoDB is not able to cope during this volume spike. So it's a performance issue in spike of the volumes, and the service in question here is DynamoDB. In case of solution architect examination and the questions, it will be mostly scenario based, and you will have multiple services. It will not be straightforward to guess the answer without elimination in most cases. So you will need to use elimination techniques, and we will see as we solve these questions how we use the elimination technique. So let's look at the options. Let's look at option D, use of SQS to queue transactions to DynamoDB. So what this particular option is suggesting is now that you have increased amount of volume in, say, orders, do not send it directly to DynamoDB, but first send it to SQS. So there will be a queue because your DynamoDB is busy and it cannot handle, say, for example, its capacity is 1,000 transactions per second, and now you're getting 2,000 transactions per second. So DynamoDB will process those 1,000 transactions while the additional 1,000 transactions will queue up. Now, this will help manage the spike in traffic because not all the orders are going to hit, or not all the transactions are going to hit DynamoDB. However, it is going to introduce latency. In terms of customers, if you are expecting confirmation of the order, or if this is a multi-stage order process where you basically process payment after that queuing step, it's all going to delay the whole thing. So this may not be acceptable for the e-commerce transaction. If you queue up the transaction, it's not going to be really a live transaction. It will be a deferred one. So we rule this out. This is not an ideal solution. Option D is out. Let's look at the next possible one for elimination. Look at option C. It says use Kinesis to queue transactions for processing to DynamoDB. Now, one thing you need to remember is whenever you see Kinesis, it will be always in the context of real-time streaming data. Kinesis is not required for OLTP transactions, online transaction processing transactions, and it's not going to help with your flash sales and the increased volume that you're getting in the flash sales. So this is not fit for purpose. You cannot use Amazon Kinesis to handle the additional amount of traffic you're getting during the spike of flash sales. So that is ruled out. So that's two options gone. Let's look at what we have left. We have left with option A and option B. Option B is implement DynamoDB accelerator for fast memory performance. And the second one is switch DynamoDB to on-demand mode during flash sales. Now both look performance oriented, will possibly boost the performance of Dynamo. Let's look at option B. So DAX essentially is a cache. So DAX will improve the read performance. It's primarily for caching frequently accessed data. But caching is for reading the data, frequently accessed data. It's not for read-write operation. It's not for OLTP transactions. So this is not going to be useful in this case, in this scenario. It's a caching mechanism. We don't want read performance here, and that's not the only problem. We want an overall OLTP transaction performance to improve, and we want DynamoDB to cope. So option B will rule it out for that reason. It is a performance solution, but it won't help in this particular scenario. So what we are left with is option A, on-demand mode automatically scales the capacity to match real-time demand. It prevents throttling and it ensures smooth performance. So whenever you have high demand on your application due to sales or flash sales or events or festival period where customers are buying more or accessing your e-commerce platform more or any other application more. This DynamoDB in on-demand mode will help. It's like auto scaling, but at the DynamoDB level. So this is our answer, option A. Here is documentation from AWS with respect to on-demand mode. And as you can see, Amazon DynamoDB on demand is a flexible billing option capable of serving thousands of requests per second without capacity planning. So there is no need for you to plan the capacity. You put DynamoDB in on-demand mode and it offers pay per request pricing for read and write requests so that you only pay for what you use. When you choose on-demand mode, DynamoDB instantly accommodates your workload as they ramp up or ramp down to previously reached traffic level. So it's not just about going up. It also, when your traffic dies down, when your number of requests, the peak has passed, it will again scale it back. So you do not over provision the capacity when you don't need it, and then based on that, obviously you don't even pay when you don't need it. So go through this particular piece of reference documentation. It's quite useful. And that's it on this question, first question of AWS Solutions Architect. Let's move on to the next question. Question number 2, management need a summary of AWS build item broken down by user as part of their budget planning process. Budgets for department will be created using the data. A solution architect must ascertain that the most effective method of obtaining the report. Which solution satisfies this criteria? Please go through the question, look at the options, mark your keywords, also identify a problem description. I hope you read the question. So the keyword here is, as I just described, we need AWS, a report of AWS billing items broken down by user, and the method needs to be very effective. So we need billing itemization as a cost-effective method. That's our problem description, as I mentioned here. So let's look at the options. And again, our default mechanism for these questions as we go on will be elimination technique, because as we go, the question difficulty level is going to increase. It's different to Cloud Practitioner exam. Cloud Practitioner exam was one service, one answer. Mostly it is all about knowing how, what is for per given problem description, what service is the solution, and the problem itself will be a straightforward application of the service. However, as we go through the questions for solutions architect, you would find that the problem description itself will get complicated and it's not easy to pinpoint one service. You will always find two options which are most likely incorrect, and you will be able to spot those, and you will end up with two remaining options, and choosing between those would be a difficult job. So our method will always be eliminate two, then look at the remaining two and choose the most appropriate from the remaining two options. Let's look at what options we have. So according to me, option D, modify a cost budget in AWS budgets to alert with simple Amazon email service. Now, this appears to be obviously wrong. This budget is for determining and creating a threshold for budget for a particular service or a group of services, and then send an alert. Not going to help with current scenario or the problem description of bill itemization. So option D is wrong for me. Let's look at anything else we can eliminate. Yeah, option C. It says access the bill details from billing dashboard and download the bill. Now, billing dashboard will provide you a high-level overview of cost, but it will lack the granularity. And it won't give you customization options as well. So if you want to go by department level budgeting, etc., it's not going to do that. You will know about service level, and the drill down is not possible. So for the given problem, it's not. It is a report, but it is not a report where you can have itemization, go by various departments, etc. So that's wrong. So I am going to eliminate both option D and C for that reason. So two of the options have gone, and we are left with option A and option B. Option A says run a query with Amazon Athena to generate the report, and option B says create a report in Cost Explorer and download the report. Both are report generation methods. Now you can do query from Athena, but you need knowledge of SQL. You have to build the SQL, run the SQL, and you will get it in a certain format. You may on itself, you will not have a good user interface as well. If you plug in Athena with QuickSight, that's a different story. So we'll rule that out. So what we're left with, option B. Now, option B says create a report in Cost Explorer and download the report. Now, Cost Explorer provides you granular cost breakdown, including breakdown by users, service, regions, and tags. It has customizable reporting. You got downloadable formats, CSV, PDFs. So then you can share it with your stakeholders or give it to analysts for further analyzing it. You can facilitate collaboration with management and department heads. So this is an accurate answer for this particular question. Option B is the answer for question number 2. Let's look at some AWS documentation around this as well. So if you see this particular page, and you will get the link for this in the video. analyzing your cost with AWS Cost Explorer. And you could see AWS Cost Explorer is a tool that enables you to view and analyze your cost and usage. You can explore your usage and cost using the main graph. The Cost Explorer cost and usage report or the Cost Explorer RI report. You can view the data for up to 13 months. So there is storage of 13 months, and you can also forecast how much you are likely to spend for next 12 months. So it's not only helps you analyze the current cost, but there is a, it helps you with the forecast as well. So I recommend you to go through this passage. It will help you answer any question around Cost Explorer and its usage. That's it on this question. We'll move on to the next question. Before moving on to the next question, if you're finding this series helpful and you haven't subscribed yet, I would recommend you to hit that subscribe button for regular cloud certification updates. Let's go to the next question. Question number 3, a solutions architect must create a system for archiving case files. The files are critical corporate assets. The file count will increase over time. Multiple application servers running on Amazon EC2 instances must be able to access file concurrently. There must be built-in redundancy in the solution. Which solution satisfies this criteria? So we need to archive the case files. We're expecting the count of files to increase over time, and we'll have multiple applications in this scenario to access the files, and concurrent access is needed. This is the most important keyword in this context. Let's go through the options and let's eliminate obvious wrong ones. So option C, a S3 Glacier Deep Archive. It is designed for long-term and infrequent access data with retrieval times of several hours. It's not suitable for active archiving where file needs to be accessed frequently, and there is no use case for concurrent file access as well. Let's take a tour on S3 storage classes. When you were preparing for a foundational exam of Cloud Practitioner, you must have seen the storage classes for S3 where you have the standard S3 access, you have infrequent access, you have one zone access, then you have S3 Glacier Deep Archive with immediate access. Now, all of these different storage classes are to store the data, and we are choosing different solutions because the cost of storage is different in each case. If you want in standard iOS 3, then you're talking about maximum amount of cost. Whereas if you are keeping it in deep archival in Glacier, which is basically equivalent to freezing something in a deep freezer, then the cost of that is going to be much lower because you don't expect it to be immediately available. So the cost of deep S3 Glacier is much lower as compared to S3 standard access. Hence, you use different types of storage classes so that it becomes a cost-effective solution. But it's not a solution for concurrent file access, so we will cross this out. That's gone. The next one, if you look at option D, AWS backup. Backup is a backup solution. It is not a solution for concurrent file system access. It is suited for backing up data from various AWS services and taking a backup, which could be then used in disaster recovery process, but not in case of this use case. So backup is gone. You're left with two now. Amazon Elastic File System, EFS, and B, Amazon EBS. Both are storage solutions. But if you look at option B, it is a block level storage for individual EC2 instance. It's not a shared file system to be accessible by multiple instances. So EBS is gone from that perspective. It's neither a file system nor it is going to give you concurrent access. So from both the requirements, that's gone. And you're left with option A, Amazon EFS, which is your fully scalable managed file system for cloud-based application. And you will have concurrent access from multiple instances for this particular file system. So that's your answer, Amazon Elastic File System. And exam tip for you, if you get any question around concurrent file access, which is what the use case here was, you need to straight away select EFS, Elastic File System, as an answer for that going forward. Let's look at some documentation as well as we come across some new services. So the first one here, Elastic File System itself, it's a serverless, fully elastic file storage. It's a managed service. You don't have to manage servers. And you can see it's highly durable and highly available. 11 nines in terms of durability and 4 nines in terms of availability. The next one, Amazon S3 Glacier. It's a long-term, secure, durable storage class for data archiving at lowest cost and millisecond access. So you can see it's a cost-effective solution for archiving. It's like your storage. It's like your garage. It's like your external storage for stuff you need in life. That it's equivalent service in case of AWS for data. Go through this particular page. Look at this video as well. It would help you understand the purpose of this service better. If you look at the benefits at the bottom, you can see this one also has unmatched durability and scalability, and it's quite a secure solution. We'll move on to the next one. And then we saw AWS backup as well, like a backup service, but it's a cloud-based backup. Please go through this service, understand it better for future purposes. So I believe that was the last thing on this particular question. We'll move on to the next question. Question number 4, a corporation connects its on-premises servers to AWS through a 10 gigabits per second AWS direct connection. The connection workloads are crucial. The organization needs a catastrophic recovery approach that is as resilient as possible while minimizing the existing connection bandwidth. What recommendation should a solution architect make? Please read through the question. This is a networking question, and I have told you in Cloud Practitioner series, whenever you have networking question, it's kind of complicated and it's quite wordy as well. Here's my version of keywords. We need a disaster recovery solution for on-prem to AWS. We already have a direct connection, and we want a resilient solution. So let's go over the options. We'll again use elimination technique. Let's look at the first one. The first one says set up a new direct connection in another AWS region. Now, if you do this, this will offer redundancy, but it doesn't utilize the existing 10 Gbps bandwidth in the current region. So potentially this will be higher cost and not much benefit. So I don't think this is a correct example. So we rule that out. The second one is, the option B, set up a new AWS managed VPN connection to another AWS region. VPN are not reliable and have much lower bandwidth as compared to direct connection. And it will be not a suitable example for crucial workloads if you have important workloads like in this particular scenario. Additionally, public internet dependency introduces high latency, potentially security issues come with VPNs. So as compared to direct connect, this is not a correct solution. I would rule this out. So option B is gone. VPN is not for resiliency in this case. Then what do we have? Let's look at option D. It says set up 2 new AWS managed VPN connections. One in AWS, currently AWS region, and one in another. As we have already discussed, VPN is not, whether it is one VPN, two VPN, it's not the right solution for resiliency, right solution for critical workload. So this is gone as well. So for the same reason of it's not the right network solution, P and D both are gone, and we are left with option C. It said set up 2 new direct connections, one in current region and one in another region. And let's look at this with the help of a diagram. So this is what the current scenario is. You have an on-prem network and you have your resources in there, and you have a direct connect solution, and you have in one region. Now, what we are saying, our solution basically says, all right, build one more direct connect between on-prem and your current region. So that gives you resiliency over there. So if one direct connect fails, you have another one. And if the region fails, you have another region, build that one and deploy your resources there and build another direct connect to that another region. So here you get, if there is a failure within region of direct connect, you have resiliency. And if there is a major disaster, and that's what when we say disaster, it's at, availability zones have gone, a possible region has gone, then you have your application stability and continuity from your region 2. So you establish 2 more direct connects. So you have 3, 2 for region 1 and 1 for region 2. And that's what it is. And this solution, I would like to go a bit more in detail in terms of what it provides. Let's look at some aspect of this particular solution. You can read it at your own pace, but essentially this solution provides you resiliency. It does bandwidth minimization because you are trying to use an existing solution as well. Disaster recovery because we have now redundancy built in the solution for within the region as well as across another region. You have this is quite suitable for disaster recovery. So that's it on this question. Let's move on to the next question. Question number 5. Currently, a company's legacy application relies on an unencrypted Amazon RDS MySQL database with a single instance. All current and new data in this database must be encrypted to comply with new compliance standards. How is this to be achieved? So here is my version of keywords. We have an application with a database, Amazon RDS MySQL database, and it's unencrypted. It is in a single instance. All of this data we want to encrypt now. So an unencrypted database, we want to encrypt. So what is the solution? This is a key concept, and you probably will get questions with slightly different variants around this. Option 1 itself says create an Amazon S3 bucket with server-side encryption enabled. Move all the data to Amazon S3 and delete the RDS instance. S3 will offer encryption in this case, but it's not a suitable database replacement. We have a database. We cannot put the database data in S3. S3 is a object store, and this solution is not going to work. So we rule that out. It's a mismatch of data format, and it's not suitable in terms of storage. Let's look at option B. It says enable RDS multi-AZ mode with encryption and rest enabled. Perform a failover to the standby instance and to delete the original instance. Now, by doing this, what you're saying is you enable multi-AZ mode and enable the encryption. Now, that's fine. Then a new data comes in, it will be encrypted. But what about existing data? Existing data is not going to automatically encrypt. So, and this also will involve downtime. So we don't want downtime as well in this situation. So this is an incorrect option. By doing this, Anything that is newly added data that gets added to the application, maybe it's orders or maybe something else, maybe custom data, all of that will be encrypted. Whatever is existing will remain unencrypted. So that's gone. So we delete that option as well. From remaining options, which is C and D, let's look at what. Or D says read replica. Now, read replica with encryption at rest enabled, promote the read replica to master and switch the application over to the new master. Read replica is not actually used for OLTP or read write transaction. This is good in case of reporting, and this will also involve a downtime for the RDS instance, and it won't be feasible for large databases. So we rule that out. I don't think this is the correct solution. So that's gone. And we are left with option C. It says take a snapshot of RDS instance, then create an encrypted copy of the snapshot and then restore RDS instance from the encrypted snapshot. And this is the right solution. And look at this particular diagram. You have an encrypted RDS instance, you have a database snapshot, you take the copy of DB snapshot with encryption, and then you basically get your encrypted RDS DB instance from it. It's the right solution. This, and the beauty of the solution is you have minimal downtime. You get encryption at rest. You have data integrity in application compatibility, because we're not doing putting a database into an object store. Please remember this diagram whenever you get a question around, oh, we have an existing database with no encryption and we want to then make sure that all the data gets encrypted. You need to follow this process. You need to use DB snapshot. You cannot just set the configuration of your database to encryption and it won't automatically start encrypting. Existing data has to be encrypted. You need to use this mechanism. I believe that was the last question in this episode. That brings us to the end of this episode. I will see you in the next episode of this series soon. If you like the content and want to get notified when I release the next episode of this series, then please subscribe to this channel. This is Exam Tricks and Tips. See you in the next episode. Thanks for watching.